And we're back to Algebra 2. Today's lesson is 2.7, Factor Completely. So when we think about factoring completely, I always think 2 words, 2 steps. So once you factor the first time, it's going to ask you to factor one more time. But before we get into that, let's start with some practice here in exercise 1 that says write each of these in expanded form using multiplication or distribution. So when I see a situation like A, the first thing I usually like to do is I usually like to factor my 2 binomials first, because I can do that pretty quickly, at least in my head I can do it. So this becomes x squared plus 4x plus 7x plus 28, which is x squared plus 11x plus 28. But don't forget that we have a 2 out front. So we have to make sure that we multiply this through by 2, distribute the 2 out. So we get 2x squared plus 22x plus 56. Going on to B. Can I move this over a little bit? Yeah, I can. That's good. Get it out of the way. All right, B. So I'm going to do the same thing. I'm going to multiply these 2 first. So I'm going to get 5 times 2x squared plus 6x minus 5x minus 15. Again, I'm going into the other problem there. So I get 5 times 2x squared plus 1x minus 15. So now multiply through by 5. 10x squared plus 5x minus 75. Try to write a little smaller now, because I seem to be moving in, although this one isn't quite as bad. So if you consider these 2, this is remember, a conjugate pair. So I know when I multiply these 2 together, I'm going to get x squared minus 25, because the middle terms are going to cancel out. Just to remind ourselves, x squared plus 5x minus 5x minus 25, and those middle terms cancel out. So I have no linear term. But remember, now I need to multiply this through by 3. So I get 3x squared minus 75. And the last one, again, we have a conjugate pair here. So the middle terms are going to cancel out. So it's just going to be the first and the last. So it's going to be 9x squared minus 4. Multiply through by 4x. And I get 36x cubed minus 16x. So hopefully you're realizing where I'm going with this is that now we're going to work this backwards. We're going to start with our answers and work up to what we started with in A, B, C, and D. Again, if you need to stop, pause, write things down, it's always good to watch first and then pause it and write everything down. So to completely factor an expression means to write it as a product, which includes binomials that contain no greatest common factors. All right, factor completely, like I said, 2 words, 2 steps. So consider this trinomial, 2x squared minus 4x minus 6. So the first thing I always look for is a GCF. So I'm looking through and I see 2, I see 4, and I see 6. So I know that I can factor out a 2 out of this. So remember, when I factor out a 2, what that basically is telling me is I'm going to divide a 2 out of each of my terms. So when I'm done, I'm still going to end up with 3 terms. So I have x squared minus 2x minus 3. And if I wanted to give it a quick check, I would just distribute the 2 to come up with the 2x squared minus 4x minus 6, which is what I started with. Okay, so in practicality, it is always easiest to completely factor by looking for the GCF first of the expression, and then once removed, factoring then either consists of the difference of perfect squares or a standard trinomial. So let's move on to exercise 3. Maybe if I do this, I'll be able to stay within the confines of the problem. All right, so first one, 4x squared plus 12x minus 40. So I'm hoping you realize basically what we do is we look here and we look at the smallest of our coefficients, which is a 4, and 4 does go evenly into 4, 12, and negative 40. So let's start with factoring that out. And remember what that means. It means I'm going to factor out or divide out a 4 out of each term. So I end up with x squared plus 3x minus 10. And then the next step is going to be to factor that again. So when you have a leading coefficient that's 1, we can just read this backwards. So we put our x's in. We know because this is a minus, we know the signs are going to be different. That's what this sign tells us. Different signs. So I know I'm going to have a plus and a minus. And now I'm going to read it backwards and say what two numbers multiply to 10 but subtract to give me 3. Well, 5 times 2, but because this plus right here is kind of dominating, we need the bigger number to be the plus. So the 5 has to go here and the 2 has to go here. So that way when I loop it, I get a positive 5x, I get a negative 2x, and that adds to get a positive 3x, which is what I want right here. Moving on to B, 6x squared minus 24. Again, I'm going to look at that 6, and 6 goes into 24 as well. So I'm going to factor out a 6. So factor out a 6, and I'm left with x squared minus 4. And hopefully you recognize that as the difference of two perfect squares, or dots, which result in our conjugate pairs. So you get x plus 2 and x minus 2. Remember, if it says factor completely or completely factored, you're looking for 2 steps. So always think about what that last step is. If it's something that doesn't make sense, maybe you made a mistake the first time around. See, again, because 2 is the smallest number I have and it goes into evenly into every term, factor out a 2 to get x squared plus 10x plus 25. Keep the 2 and factor x and x. In this case, the signs are the same and they're both positive because I look right here. This tells me the signs are the same and this sign tells me they're both plus. So what two numbers multiply to 25 but add to give me 10? I read it backwards. Add to give me 10, obviously 5 times 5. So hopefully you're saying, well, these are easy. All right, and this last one, we have 75 and we have 3. Well, we're not going to take a 75 out, but we can take a 3 out. So if we divide each of these by 3, I get 3 parentheses 25 minus x squared. Now beware, in this case, remember that order counts. If 25 is in the first position, the square root of that, which is 5, is going to be in the first position of our binomials. Our signs are plus and minus. Does not matter what order you put it in. And x and x. So that's going to be adopts. Now beware, see the difference here between this one and this one? This is x plus 5 and 5 minus x. This is x plus 5, x plus 5 on this side. All right, that is not adopts. That's basically, you can rewrite this one as 2 parentheses x plus 5 squared, which is not the same thing. Finish writing down what you need to and meet me at exercise 4. Okay, so completely factor each of the following. Completely factor 2 steps. So sometimes it isn't always as obvious what your GCF is. In this case, when I look at A, I notice that 10 does not go into evenly to 55 or 105. So you consider the next largest factor of 10, which is 5. So 5 does go in evenly. So we can factor out a 5. So when I factor out a 5 out of each one, I get 2x squared plus 11x plus 21. I'm sorry, I'm just looking at that's supposed to be a minus 21. Right? Okay, because it was not factoring well. So here we go. These sometimes we can do in our head a little bit when you have a prime leading coefficient, and it turns out to be 2x minus 3 and x plus 7. Remember, you can always use the box method here. How about we do the next one with the box? Because sometimes it's not quite so easy to come up with the answer. So let's look at B. B, well, you look at 12, 57, and 15. Well, I look at the 12 and the 15, I think, well, 3 goes into both of those, but does 3 go into 57 evenly? And it does. So we're going to factor out that 3, and we end up with 4x squared plus 19x minus 5. So now we're going to keep that 3 on the outside, and we need to factor this into 2 binomials. So because it's not obvious to me, let's head to our handy-dandy box method. Let's see if you remember how to do this. Box method. So I know I have a 4x squared here. I have a negative 5 here, which means now I'm going to go to my crisscross worksheet, put the negative 20x squared up here, and the middle number, 57, goes here. Oh, not 57, duh, 19. That seemed really big to me. Remember, this is the one we're working at here. So 19. So I need 2 numbers that are going to multiply to negative 20, but they're going to subtract to give me 19. So go to your, you can go to your little list over here, 20. So that's pretty easy to me. It's going to be 1 times 20. So I'm going to have 1x and 20x. They're going to subtract. The 19 is dominant. It's plus, so this is going to have the plus. This is going to have the minus. Minus 1x here. 20x plus 20x here. So now GCF of 4 and negative 1 is 1. GCF of 4 and 20 is 5x. So that means this one down here has to be a negative 1. This one up here has to be a positive 4. So my answers are going to be 5x minus 1 and x plus 4. Okay, so that was completely wrong. Let's look at that again. This is not right. I'm looking at it, I know it's not right. And I know it's not right because 5 times 1 is not 4. All right, so let's try that one more time. This has to be a 4x. This has to be a 1x. This has to be a plus 5. This has to be a minus 1. So the answer is 4x minus 1 and x plus 5. Okay, that makes sense. See, even the best of us make mistakes once in a while. Not saying that I'm the best of all of us, but it happens. All right, let's move down to C and D. You know what? Why don't you try C and D? and come back to me, and we'll put the solutions on here. Okay, so solutions for C. Bam. So this one actually wasn't a two-stepper. So it would not normally say factor completely if it's not a two-stepper. I think that was probably a typo. And the same thing with D. D is not a two-stepper either because no number goes into 12, 29, and 8. So this is going to be a one-stepper too. So a little bit of a hint. So you ready? Here are the solutions. Bam. So those happen to be two that are not factoring completely, but I promise you, if it does say factor completely, it will be two steps. So moving on to exercise 5, sometimes the two steps don't include a GCF, but still requires factoring twice. So these are fourth degree polynomials. So if you take a look at this one, we're going to factor this exactly the same way we would factor a quadratic. But in this case, we're going to take half of the degree 4, which is degree 2. So x squared and x squared in the first position. Now we're just going to read it backwards like we did before. 2 factors of 4 that subtract to give me 3. So obviously we're going to have 4 and 1. And because the signs are different and the minus sign is dominant, we're going to have a minus 4 and a plus 1. Now, hopefully you notice right here that we have a difference of perfect squares, which is going to result in our conjugate pairs. Don't forget about the x squared plus 1 off the back because we can't touch that one. So we factored it twice. B, same thing, x squared in the first position. Read it backwards. What are the multiples of 18 that add to give me 11? We know the signs are the same and they're both minus. Because the only way we can get to a positive 18 is to have two positives or two negatives. And this sign right here tells me that they're both negative. So we're talking about 9 times 1. 9 times 2, of course, is 18. And here we have our difference of perfect squares. This is not a perfect square. 2 is not a perfect square. It can be solved, but we're going to get into that later on in the unit or in the course. So the only thing we're going to do right now is we're going to say x minus 3, x plus 3 times the x squared minus 2.
Good afternoon, we have.
Okay. We are done with this lesson for now, and we are going to move on to the independent practice. Whatever the homework is for tonight, if it tells you to get the independent practice done, get it done. You can probably even start this a little bit because I feel like you can do this without help from your people, but you're going to continue it with your people tomorrow. So have a nice afternoon, evening, or otherwise, and always make good choices.